Before we go further to the code, I would like to introduce briefly information about the function of the MAX sensors, also known as the MAX 30102 pulse oximeters and heart rate sensors. These sensors consist of a photodetectors and a pair of high-intensity LEDs, which are late and infrared LED. The sensors works by shining both light onto the fingers and measuring the amount of reflected light using a photodetector. The working of the sensors can be divided into two parts. The first one is heart rate measurements, and for the second one is pulse oximeters. For the first one, the oxygenated hemoglobin in the arterial blood has the characteristic of absorbing infrared light. The redder of the blood means that the more of infrared light is absorbed. As the blood is pumped through the finger with each heartbeat, the amount of reflected light changes, creating a change waveform at the output of the photodetectors. As you continue to shine the light and take the photodetector readings, you quickly start to get a heartbeat pulse reading. For the second part is pulse oximeters, based on the principle that the amount of red and infrared light absorbed varies depending on the amount of oxygen in your blood. The oxygenated blood absorbs more red light, while the oxygenated blood absorbs more infrared light. By measuring the ratio of infrared light and red light received by the photodetectors, the oxygen level in the blood is calculated.
For the coding, first we need to add the library here. This one is the library that allows us to communicate with the Arduino IDE. And this one is for the I2C communication. This one is for OLED. This one is for the MAX 30102 sensors. And this one is for the billing application. And I define the OLED device here as the screen it has width around 138, the height 64, and the screen address is 3C. And as the Arduino Uno doesn't have enough RAM to store 100 samples of the IR LED data and the red LED data in 32 bits format, so we need to change it into 16-bit data here. And this one, the billing application, this one, it will pop up after you create a new project in the billing application. In each work, it will have a specific template ID and the device name and the link token. And this helps us to connect the server in the billing application with this code. And this one is for the Wi-Fi user and the Wi-Fi password that we need to connect. And I have already created a data stream in the billing application v4, and I will display data v4 in the LCD. And this one display the button message of the congratulations in the billing applications after it connect properly. And for the voice setup, I start with the serial begin. That this one is for checking the serial monitor and begin the billing. This one is to set up the max sensor according to this value, and this one is for the OLED device. I need to show this message or this topic on the OLED. And before we go further to the loop, we will clear display first. In the loop, we'll start with the blink. I will set it to run, and the buffer range equal to 100 samples, and read the first 100 sample and determine the signal range. Like this one is to check the data. If not have the data, let's check to the sensors. And here is to get the LED LED and the infrared LED value. And when finished, go to the next sample. And here is to display in these visual monitors to calculate the heart rate and the SpO2 value. After the first 100 sample received, this tool continuously taking the sample from the max sensors. And this one is for dumping the first 25 sets of sample into memory and shift the last 75 sets of sample to the top. This one is take 25 sets of sample before calculating the heart rate and check it have the data or not. If not, check the sensor to receive a new data and get these two value again. If finished, go to the next sample and send samples to the serial monitors. Display the heart rate and the SpO2. This one is for the link application. I need to show the heart rate and the SpO2 value in terms of string in a value display of the mobile Bing application. And this one I want to show it in a gauge. So I need to change it the data type into the integer first before display it on the gauge. And I need to create a new data stream here. As you can see that these two are different with this one, even though it's in the same value, but it is in the different data type. And here's to display the LCD. I will display the heart rate and the SpO2 value. This one is for clear display before print view value in the LCD. And I also create a condition here. If the heart rate is in between 60 to 109, the LCD will print normal, but if not, it will print the abnormal. And this for the SpO2 value. If the SpO2 value in the range of 93 to 100%, it will show as normal, but if not, it will show abnormal. And this one is to preventing the data overlaying as one before. After that, gathering the 25 new data sample and we calculate the heart rate and SpO2 again.